Hello, I'm going to discuss the past paper questions on your unit 2, the first few syllabus topics, okay? So the first question is, waves may be longitudinal or transverse. Which of the following statements is correct? So you need to find out the correct statement. We can check each option. So the first one is, all transverse waves travel at the same speed, which is wrong because light wave, water waves, all are transverse waves, but they are not at the same speed. So option B is, all transverse waves have vibrations that are parallel to the direction of wave travel. That's also wrong because if the vibrations are parallel, then it is a longitudinal wave. In the case of transverse waves, the vibrations is perpendicular to the direction of wave travel. Then option C is, both transverse and longitudinal waves can be refracted, which is true because light and sound both can be refracted. Then option D, no transverse waves can travel through liquids, which is wrong because the light is also a transverse wave. It can travel through liquids, right? So the correct option would be option C. Then the second question, waves can be represented on graphs of displacement against distance and displacement against time. Which of the following properties can only be determined by combining information from both the graph? So we can check each options. So the first option is amplitude. So in the case of displacement distance graph, you could find out the amplitude. In the case of displacement time graph also, you could find out the amplitude. Both the graphs will give you the amplitude because it is having displacement on the y-axis. So amplitude is the largest displacement from the equilibrium position, right? So you don't need the information from both the graph. You just need either of the graph. So the option B is frequency that you could find out from the reciprocal of the time period. So in order to find out the time period, you just need the displacement time graph, right? So you don't need the information from both the graphs. So option B is also wrong. Then option D, wavelength that you could find out from the displacement distance graph, because if this is a displacement distance graph, this length is representing the length of one wave, right? So you just need displacement distance graph to find out this. But the option C, which is the correct option, wave speed, right? Wave speed formula is frequency multiplied by the wavelength. So in order to find out the frequency, you need displacement against time graph. In order to find out the wavelength, you need displacement against distance graph. So you need the information from both the graph to find out the speed value. So the correct option would be option C. Then the third question. Active noise reduction, ANR, is a system used to reduce unwanted noise. In ANR, a second sound wave is produced that cancels the first. ANR is used in aircraft to reduce the noise heard from the engine. So the question number A is, on a particular flight, the noise from the engine has a frequency of 0.85 kilohertz. The graphs shows a possible second wave. So how a wave can cancel the previous wave? The wavelength must be the same, right? So we can check the question. Determine whether this wave could be suitable to cancel the noise from the engine. So it's just like an overlapping. So the wavelength must be the same. You can find out the wavelength from this graph itself because it's a displacement distance graph, and here the distance is given for 5 divisions as 0.5. So the 4 division, which is giving you the wavelength, is 0.4. So 0.4 meter is the wavelength that is given in your graph, right? So the speed of sound is also given here. So if you know the frequency, which is equal to 0.85 kilohertz, which means a 10 to the power 3 hertz, and the wave speed is 330 340 meter per second. 340 meter per second. So wave speed formula is frequency multiplied by wavelength, which means that the wavelength is wave speed divided by frequency. So the wave speed is 340 divided by the wave frequency is 0.85 multiplied by 10 to the power 3. If you do the calculation, you will be getting 0.4 meter as the wavelength, which means that both the waves that you calculated for the noise from the engine and the wavelength given in this possible second wave are the same, which means that this second wave can cancel the noise from the engine. Then question number 4, a graph of displacement against time for a point on a transverse progressive wave is shown. So here we are dealing with the progressive wave. We have one more kind of wave which is called stationary wave or standing wave. We'll be discussing that soon. So in this graph, which of the following statement is correct? So we can check each options. So the first option is the amplitude is 20 centimeter. You know, the amplitude is the maximum displacement from the equilibrium position. This is the equilibrium and the maximum displacement is 10 centimeter. But here it is given as 20 centimeters, so the statement is wrong. Then option B is the frequency is 2.5 hertz. We can check. Frequency equation is 1 over t, right? So here the time period for one wave that you could find out, the wave starts from 0.1 and ends on 0.5, which means that 0.5 minus 0.1 is the time taken for one wave, which is 0.4, which is equal to 2.5 hertz, which means that this option is correct. You can check this option C also, because the time period is 0.2 given, but you know the time period is 0.4, which is wrong, and the wavelength you could not find out from this displacement against time graph. So this option is also wrong. So the correct option is option B. The frequency is 2.5 hertz. Then the question number 5 is, a wave has an amplitude of A, period t, and wavelength lambda. Which of the following can be used to calculate the speed of the wave? We know the speed of the wave equation V is equal to F lambda. And you could substitute for F in terms of time period like 1 over t multiplied by lambda, which means that wave speed is equal to lambda over t. So it clearly mentions the option D is the correct one. Then the question number 6. Which of the following statement is correct for minimum displacement of the particles in a longitudinal wave? You can find out this answer by studying this longitudinal wave graph. Okay, you could find out from my previous video. So here the option, you know that minimum displacement will occur at compressions and rarefaction in both. So the option C is the correct one. The center of the compressions and rarefaction will be at the minimum displacement. The other particles will be having the largest displacement that creates compressions and rarefactions at 2 points. So the question number 7 is, a student is used the apparatus shown in photograph 1 to determine the speed of sound in air. So this is one of the experiment that's also given as your core practicals. So here there is a 2-beam oscilloscope given and a signal generator, microphone, and a loudspeaker. So microphone will be receiving the sound that is created from the loudspeaker. The student switched on the signal generator. The oscilloscope showed one trace from the signal generator and another trace from the microphone. I hope everyone know the working of oscilloscope. If it is to visualize the waves, if you don't know how to use the oscilloscope, just tell me on the comments. I'll do a special video on the working of the oscilloscope. Okay. So here the oscilloscope showed one trace from the signal generator and another trace from the microphone. Okay, initially the peaks of one trace were directly above the trough of the other trace, as shown in this photograph too. So this crest and the trough are coinciding. Okay. So this is the wave that you are receiving on the oscilloscope. Explain how the apparatus shown in this photograph could be used to determine the speed of sound in air. You know that speed of sound in air you could find out from this formula, right? So from this oscilloscope you could find out the frequency by just finding the time period. Yes, you know the time period that you could find out by multiplying the number of divisions by the time basis, how much time that you are given for division. And the lambda is the trickiest point here. So the point is, you are placing this microphone over here, which is at a particular distance from the loudspeaker, and the distance also you could find out from the reading on this meter rule. Okay, I'm just marking this point now, and I know this would be the graph. Okay, and as I'm moving, so one wave is from the microphone. I think this one would be from the microphone, because the other one is having the trace from the signal generator itself, which is having the higher amplitude. You know the amplitude is representing the intensity, right? The strength of this. So as the second this wave is having low amplitude, this must be the wave that is received by the microphone, because the loudspeaker is here and the microphone is here. Okay, so I mark this position and I'm moving this one along towards the loudspeaker. So as I'm moving, what I'm observing is this wave position will be changing. Okay, and it will be moving, this point may move to this side and it will coincide at this position. You will be getting the same picture as you're moving after some time. So where you're getting the same picture again, just stop the microphone over there and measure this length, and this length would be the wavelength. Okay, so from this position to this position is the wavelength, right? So you could find out the wavelength using this method and the frequency by using some calculations. That's how you will be doing finding the wave speed by the calculation. Question B from the same question. The student changes the position of the microphone. The traces on the oscilloscope screen before and after changing the positions of the microphone are shown in the photograph 2 and photograph 3. So these are the photographs. So you could change some changes in the amplitude, right? Explain what change the student made to the position of the microphone between photograph 2 and photograph 3. So you may find out that the amplitude of the trace, the first trace is changes, that is increases, which means that the sound received by the microphone is increases. For that, the microphone has to be moved towards the loudspeaker. So if it is moving towards the loudspeaker, what happens? More will be the sound intensity it is receiving, so the amplitude will also be increasing, right? Then question number 8. A sound wave travels through air. The diagram represents the displacement of air particles along the wave at an instant in time. So this is a displacement distance graph. Okay, there is a compression at position V. Okay, At which position is there is also a compression. If this is the compression, you know, the other then the next displacement, zero displacement, will be for the rarefaction, and next to that we will be having again the compression, so it will be Z. So the option D is the correct one. Then question number 9. In an experiment to determine the speed of sound in air, a student had held a vibrating tuning fork above a glass tube. The air column in the tube could be adjusted by raising or lowering the tube into to a cylinder containing water. When the length of the air column was L, a stationary wave with one node and one antinode was produced as shown. This caused a sound to be heard. Okay, so this is a tuning fork, here is the glass tube, and here's the cylinder containing water. Okay, so it's given here is also. So what happens is that to form the standing wave, you need an incident and a reflecting wave. Okay, so when the tuning fork is held on top of this glass tube, the sound wave will be moving in this direction towards the wave. Okay, and when it is reaches the wave, it is reflecting, creating this picture is completely wrong. When it is reflecting, it will be having almost the same amplitude. Okay, almost same amplitude, the constant phase, and so on. Okay, it will be creating a standing wave. So this is not a proper one. I'll explain how the standing waves is forming on the coming videos. Okay, so let's consider this is one of the incident wave. Okay, this is this one, and the other one is the reflecting wave. Okay, so here is only a portion of this wave is formed, right? Because this is the total wavelength that you know, but here is only quarter of this wave is shown, only this length, right? So you could find out the wavelength is quarter of this on the standing wave. The standing wave will be having only lambda by 4, which is equal to this whole length. See, in this whole length where you are getting the standing wave, only lambda by 4 is there. So the lambda by 4, which is equal to the length. Explain how the stationary wave was formed in this experiment. It is due to the superposition of the incident and the reflecting wave, and the waves is reflected from the water surface. Okay, so the incident wave and the reflector wave both will superimpose to give out the stationary wave. Okay, so here a sound was heard when the L was 19.3 centimeter. Just be careful, it is given as in centimeter. Determine a value for the speed of sound in air. So you need to find out the speed of sound, and you know the wave equation, V is equal to F lambda, and the frequency is given as 440 hertz, right? So 440 multiplied by lambda. So lambda, as I told you, in this whole length we have only the lambda by 4. The whole lambda is not there, but a quarter of this lambda. You could find out the lambda by rearranging this, because lambda would be equal to 4 multiplied by the length. So the length is given. So lambda is equal to 4 multiplied by 19.3 multiplied by 10 to the power minus 2, right? So do the calculation and find out. So you will be getting the lambda value as 0.772 meters. Okay, so just substitute here 0.772 multiplied by 440, and you will be getting a value of 3 wave speed as 339.6 meter per second. Okay, so the last question is light is the transverse wave. Describe the difference between the transverse wave and longitudinal wave. This is one of the frequent questions that we'll be having as a sub question in most of the 4 marker or 6 marker. So the main difference of this transverse and longitudinal waves is coming from the vibration of the particles. So in the case of transverse wave, the particles are perpendicular to the wave direction. In the case of longitudinal waves, the particle vibrations are parallel to the wave direction. These are the questions for this first few topics on your syllabus. I'll come up with some new topic.